Alright, nice to see you. Today we will talk about the Philadelphia experiment and about invisibility. Let's see if it works. Let's see if I become invisible. Wow, I'm invisible. Let's be visible again. Okay, so in the Philadelphia experiment, it said that the American Army during World War II managed to make an entire warship invisible. Did it really happen that way? If so, how did they do it? We'll solve the mystery together. Let me turn invisible once more. It works. This is really cool. Being invisible is amazing. Let me come back. Okay, attention. Next, we will talk about metamaterials. What are these metamaterials? They are in fact more special materials that actually make invisibility possible. Because yes, today, in the world we live in, there is a kind of cloak, just like the one in the Harry Potter movie. There is a kind of cloak that you put around objects, and those objects become partially invisible. So we will also talk about metamaterials. Once again, wow, okay. And at the end, I will answer a question. This time, the question is whether a scientist can create an electron or an auto. Let's begin. Many of you have asked me to say a few words about the Philadelphia experiment. For those who don't know, it's an experiment that was supposedly carried out by the American military during World War II. With the help of Einstein and Tesla, the United States Navy supposedly made an entire ship invisible. But is it true? Honestly, I read about this experiment when I was young. I was fascinated by it. After I got to the Faculty of Physics, I realized that the experiment was impossible, at least for that time. I understood that the Philadelphia experiment is a myth, a story. Since then, I found out very interesting things about physics, about invisibility, but I completely forgot about the experiment. Encouraged by you, I watched some YouTube videos about the experiment some time ago. They claimed that the experiment actually took place and gave many details of the story. I felt like a peasant listening to fairy tales about Prince Charming, or like a Greek listening to the legends of Olympus. And I mean that in a positive way, not a negative one. The power of a story is extraordinary. It captivates our minds and makes us live a second life. Foot frumos, who throws the comb and everything turns into a forest? Isn't that fascinating? It's like you can see the forest growing just like in Hollywood. Or the story of Medusa from the Legends of Olympus. You look into her eyes and you instantly turn into a stone statue. What a story. Watching the videos about the Philadelphia experiment, I realized that stories will never disappear as long as there are people. No matter what era they're in, people will imagine new stories. Because they feel trapped in the surrounding reality and always dream of breaking its barriers, the huge advances in technology show us that the barriers of reality can be broken. I'm speaking to you from thousands of kilometers away, without having to shout like a desperate person. In a few hours, I'm at the other end of Europe without running, with magic boots. I can see President Trump in Washington without having the eyesight of a hawk. Stories have turned into reality. With a small addition, they have become reality. Through the minds of those who understood physics, who managed to uncover the secrets hidden in the laws of nature and then used them. Those who made the transformation of reality possible were not the storytellers and creators of the legends of Olympus. They were not the shamans from African villages or the witches from the countryside, nor were they the troubadours of medieval villages or the old storytellers around the gatherings. These people kept the human dream and imagination alive, but they were not the ones who changed the world. Nor were the first to change the world the philosophers from the Greek agora. Less well known were the peasants who fitted the wheel better to the cart. They were the followers of Galileo, who understood that the language of nature is mathematics, that if you want to change nature, you have to learn to solve equations and integrals. There were experimenters like Volta, Faraday, Herbert Orbert, Tesla, Edison, who understood that any theory must be experimentally verified. What do I mean by that? That there is the fascinating world of stories and imagination, just like the one of the Philadelphia experiment. But it doesn't progress, it stays in the same place. But there is also the world of physics around us, understood through mathematics and experienced in laboratories. It may not be as spectacular, but it is the one that brings progress. I will now illustrate the difference between story and reality. In the case of invisibility, I will choose the Philadelphia experiment and a modern invisibility experiment in the field of microwaves. Let's start with the Philadelphia experiment, as you probably expect. We are told that Tesla supposedly used a unified theory of Einstein's to make the ship invisible. The ship was a destroyer that weighed thousands of tons and was about 100 meters long. To make it invisible, when you look at the ship, you shouldn't see it, but rather see what's behind it. Imagine that someone is standing behind the ship with a flashlight, shining the light toward you. Normally, the light is blocked by the ship and you can't see the flashlight. But let's say we take some optical fibers and place them around the ship from the back to the front. Now the flashlight's light reaches a fiber at the back of the ship, enters the fiber, goes around the ship through the fiber, and then comes out in front. What do we see now when we look at the ship? We'll see the light coming out of the fiber, which comes from the back of the ship. Let's cover the entire ship with fibers that go from the back to the front. Now, when we look, we see everything that's behind the ship, like the flashlight, the person holding the flashlight, and so on. If the optical fiber has a very thin wall, we won't even see that it's an optical fiber. We see directly what's behind the ship without knowing that there's a ship there. In fact, we can take the ship away from there and we won't even notice it's missing. Basically, that's what the people from the Philadelphia experiment would have done, only not with optical fibers, but with very strong electromagnetic fields. Essentially, the result was the same. It said that the light from the back would go around the ship and reach the front, just like in our example with optical fibers. The problem arises if we calculate what electric and magnetic fields we need. How can we find that out? We have to rely on the rumors about the experiment. They say that Einstein's theory was used in an improved form, where the gravitational field was unified with the electromagnetic field in a 5-dimensional space-time. We know that Einstein worked on this dream, just like the physicists Klein and Kaluza did, but we also know that none of them succeeded. That's why we should consider Einstein's simple theory, which says that an electromagnetic field can bend the path of a light ray. Why does the light ray bend? Because the electromagnetic field has energy and energy bends space. That's what Einstein's theory of relativity tells us. Normally, energy bends space very little. That's why light travels almost in straight lines. In order to bend space around a 100-meter ship so that the light following the curvature of space goes around the ship, we need a lot of energy. We can estimate the necessary energy if we remember black holes. Thus, at their edge, at the edge of black holes, there is an imaginary sphere called the black sphere. Here, space is so curved that light ends up orbiting around the black hole. So, if we have a black hole whose horizon is about 100 meters, then space will be curved enough for the light from the back to reach the front. The effect could be applied to the Philadelphia experiment ship. How big is such a black hole? The drawing next to it shows the result of the calculation. The mass of the black hole would be about 10,000 times greater than that of the Earth. This is how we found the solution to the Philadelphia experiment. On the ship, the electromagnetic field generated should have stored the energy of 10,000 Earths. The electric and magnetic fields would have formed a black hole, whose strong gravity would have pulled the people on the ship with incredible force, that it would have crushed them to the floor. To be fair, there are reports that say some sailors were embedded in the walls. But we know these things didn't happen, because otherwise a black hole would have swallowed the Earth and we wouldn't be here to talk about it. But here we are, not inside the black hole. That proves the Philadelphia experiment is a myth. Another interesting thing that suggests it was a myth is the fact that it refers to Einstein's unified theory. Why? Because it sounds so mysterious and unresolved? However, the experiment could have been done in another way. We know, for example, that light bends its path in warm air. We see this every time we look at the hot air in the atmosphere during summer. Objects appear distorted precisely because the light rays no longer travel straight. More simply, those on the Philadelphia ship could have heated the air in such a way that the light rays would bend however they wanted. But that would have been too boring, wouldn't it? Is this a reference to big things, to mysteries, to unresolved theories, like Einstein's unified theory? What are the clues that we're probably dealing with a story with nothing real in it? A real story about invisibility starts much more simply and much more boringly. If I say invisibility has been achieved but only for a small object like an eraser, not massive ships, it's less impressive, isn't it? But it's real. If I tell you that invisibility has been achieved, not for light waves where it's harder to achieve such an experiment, but for the microwave domain where it's easier. It's not spectacular, but it's real. Look at the picture next to it. You see there a ring called a cloak. The cloak is made from a special material called a metamaterial. It behaves in a special way in the field of microwaves, which are electromagnetic waves with a wavelength of around centimeters. You can also find microwaves in your microwave oven. Well, if we put a material inside the ring, it will make it invisible to microwaves. Basically, the microwaves pass through the ring without knowing that there is something inside it and without being influenced by whatever is there. The object inside the ring, together with the ring, are invisible in the microwave range. This can be seen in the drawing next to it, which shows the result of the experiment. A microwave wave, planar coming from the left, continues its undisturbed movement to the right. The wave remains planar. This is the first experimental result of a cloak that can hide things. A cloak made using metamaterials. And these metamaterials are used quite often. For example, even airplanes that try to hide from radar use such metamaterials on their surfaces. Maybe these metamaterials deserve a special episode in the future. There have been significant advances since then. For example, some cloaks have been built for visible light. In red, for instance, the cloak and what it hides are invisible. If we put such a material around the ship, the cloak that forms would hide the entire ship. Unfortunately, however, the technology is not advanced enough because it doesn't work with all colors yet. So we see how invisibility is partially achieved in practice. The Philadelphia experiment remains a fascinating story, but unfortunately, it's not true. Instead, physicists work with smaller objects and are less ambitious. I have no doubt that in over 1 million years, cloaks will be made that, who knows, might hide a person or maybe even a ship. Alla Balla Portocala asked me this: can a scientist create an electron or an atom? I have to tell you from the start that a scientist is not a creator in the true sense of the word. A scientist only transforms things from what already exists into something else. He cannot create, at least for now, something out of nothing, out of absolutely nothing. He needs to have something to start with. From this point of view, it would seem that we can't create electrons if electrons didn't exist before. That's not quite true. For example, we can easily create electrons from nearby atoms. Free electrons don't exist, but breaking atoms releases electrons and scatters them. You could say, but the electrons were already there. Okay, the electrons, but pay attention, are actually packets of energy of some special fields called quantum fields. Since they are packets of energy, they can actually come from other packets of energy. That is the essence of changing particles from one form to another in quantum mechanics. Yes, in quantum mechanics. A ray of light that is near a strong electric field can generate a pair of two particles. an electron and a positron. The positron is the antiparticle of the electron. So, let me explain once again. A ray of light that apparently has neither an electron nor a positron. It only has light or particles called photons transforms into an electron and a positron. So scientists can create, if they want, electrons from rays of light under certain special conditions. You might ask, okay, but where did the electron come from? Where was it before? Well, as I said, in quantum mechanics, the electron is a packet of energy. It can appear because that energy comes from another packet of energy, in this case, the packet of energy of light. This is my answer. And more details about this wonderful world of quantum mechanics, of quantum theory, of fields, you will find them in a presentation I gave at ATN almost a year and a half ago, where I talk about these processes. The link is in the description. At the end, I have good news for you. Many of you have asked me where you can buy Povestita Physics. As you probably noticed, it's sold out pretty quickly in the last month. So in the last month, the book hasn't been available at any online or neighborhood bookstore. Fortunately, Humanitas Publishing House, where the book was released, decided to launch a new edition. So, starting today, Physics Told as a Story can be found at several online bookstores, and it's also available at some neighborhood bookstores in a week or in 2 weeks. I suggest you buy it as soon as possible because honestly, I really don't know how many copies this new edition has. Don't forget. Goodbye.